Welcome, everybody. My name is Ethan Knight with Western Water Assessment here at the University of Colorado Boulder. Thanks for joining us today. In this webinar, WWA research scientist Seth Arens will summarize weather conditions from fall and winter and provide insight into how the remainder of the water year may unfold. Before we get started, I want to share a bit about Western Water Assessment for those of you who have not worked with us in the past. Western Water Assessment is an applied research program that produces usable science to help address real-world climate problems. We are based at the University of Colorado Boulder, the University of Utah, and the University of Wyoming, and we work in the Intermountain West, specifically Colorado, Utah, and Wyoming. Western Water Assessment is one of 13 teams in the NOAA Climate Adaptation Partnerships, or CAP program, formerly known as the Regional Integrated Sciences and Assessments, or RISA program. The next slide. Western Water Assessment, we are working to build resiliency in water systems and communities in our region while working on many climate-related issues, ranging from water resource management and drought to climate adaptation and resilience to compound hazards. Next slide. Oh, Seth, the other. Yeah. Thank you. Western Water Assessment differs from a traditional research program because our goal is to produce usable science that helps address real-world problems by directly working with communities, resource managers, nonprofits, and other partners to tailor our work to their needs or priorities. This sometimes takes shape as original research, and other times involves research integration, including things like workshops, webinars, online tools and resources, or technical reports like climate summaries and assessments. Other times it involves providing expertise or presenting at a community or partner meeting. And one more slide. We can connect across a number of activities listed on the slide, including climate information synthesis and tools, vulnerability and adaptation exploration, connecting with partners, and more. If you are interested in connecting with us, you can email us at wwa@colorado.edu. Today's presentation will be recorded and lasts about 30 minutes, followed by Q&A. Please feel free to submit questions via the Q&A window at the bottom of your screen. We'll be sure to share a link to the recording with you once it's up on our website. And one more thing before I hand it over to Seth, I have a request for everybody. Please be sure to take our survey before you leave today's webinar. It should only take 1 to 2 minutes of your time, and it will help us plan new webinars and communicate with our funders about our program's impact. So I'm going to leave the link to the survey in the chat right now, and I will send it out again at the end of the presentation. And with that, I will hand it off to you, Seth. Thanks.
Thanks, Ethan. All right, my name is Seth Arens, and today we're going to be I'm going to be giving you a little summary of the 2024 water year and where we're at in that water year. But first, I wanted to talk a little bit about the 2023 water year. The 2023 water year was, in much of our region, a very, very above average water year. I'm based in Utah, and in Utah, it was a record snowpack year statewide, and many river basins also had record snowpack. And we saw record snow across the state of Utah in the Dolores, Lower Green, Jordan, Provo, Lower San Juan, and Weber River basins. The highest or the second highest SWE values were recorded at 91 SNOTEL sites across our region. So in Colorado, Utah, and Wyoming. Most of those record SNOTEL SWE levels were in Utah and Western Colorado. Also, 2023 was the third highest SWE recorded in the entirety of the Upper Colorado Basin since the early 1980s. This snowpack led to very high seasonal streamflow volumes. The inflow to Lake Powell was 166% of average in the 2023 water year. This led to a rise in water levels in Lake Powell by about 65 feet and in Lake Mead about 30 feet. This was the highest streamflow volumes that we saw were typically in Utah and Western Colorado. During the 2023 water year, we saw moderate La Niña conditions throughout the winter. What we saw in terms of precipitation and snowfall in our region and across the West really didn't match what we typically expect to see with La Nina conditions at all. It was really an anomalous winter. The record snows that we saw really don't have any other analog in many of our years across the region. Despite the really high snowpack, we saw little regional flooding. Fortunately, starting in early April, weather conditions throughout April and May were not very wet, pretty dry, and we saw periods of warmer temperatures followed by periods of cooler temperatures, so that snowpack melted off relatively slowly. This was also really well-timed drought relief. Nearly the entirety of the state of Utah, much of western and central Colorado, and southern Wyoming were in drought going into the 2023 water year. Much of the drought conditions throughout our region were alleviated during the 2023 water year. It also was very timely with thinking about reservoir operations and reservoir levels in the upper Colorado River Basin. If there had been one more year of drought conditions, the water levels in Lake Powell would have gotten to dangerously low levels, at least dangerously low when considering management of that reservoir and how water is released from that reservoir. And I really just bring up the 2023 water year in context of talking about this water year, the 2024 water year, is sometimes after we have these really, really big water years, the following year can be a little bit of a letdown, both from as managers, from a management standpoint, and even on personal levels, those of us that like to see wet winters, that like to see that snow. And overall, 2024 wasn't really a disappointment. It wasn't a huge water year like 2023 ended up being, but it was a pretty good water year throughout much of the region. So now I'm going to just go through some of what we saw in terms of water and temperature and stream flow and snowpack conditions throughout the 2024 water year and kind of where we stand right now. This map here shows total water year precipitation across the western United States. And you can see in our region, Utah, Colorado, and Wyoming, there was a mix of above and below average precipitation. We saw a pretty slow start to the water year. There was decent precipitation in October, but November and December were very dry across the region. In general, we saw above average water year precipitation. This is through yesterday. Along the Front Range in Colorado, in northwestern Colorado, northern and central Utah, and parts of southern and central Wyoming. Below average precipitation was recorded in northeastern Colorado, southwestern Colorado, much of eastern and southern Utah, and northern Wyoming was quite dry. So I just wanted to show a slightly different way of looking at water year precipitation. This map here now breaks precipitation into percentiles. So above average precipitation is years that are in the top third of years for precipitation, whereas much above normal would be in the top 10% of years. So the top, say, 13 years that we've seen in terms of water. And this shows really some of the same patterns that we just discussed. It's generally wet in northern Utah, central Wyoming, and northern and eastern Colorado. The driest conditions were in northeastern Wyoming, and this is where we saw the development of drought during 2024. Overall, temperatures were warmer than average during this past water year. Not hot like some winters we've seen over the last 10 years, but above average temperatures. Generally, temperatures were 2 to 4 degrees above average throughout much of the region, with the warmest conditions occurring along the Utah-Colorado border and in parts of Wyoming. Now, if we look at this just on monthly temperatures, March was the only month with below average temperatures throughout this past winter. Again, just looking at temperatures in a slightly different way in this temperature percentiles, you can see the entirety of the West now is covered in warmer temperatures. So we're either seeing temperatures that were in the top third or top 10% of years that have been observed. And this is kind of what we'd expect with El Nino conditions. We saw warm Pacific Ocean temperatures off the coast of South America throughout the entirety of the winter. This triggers El Nino conditions when the Eastern Pacific Ocean is warmer. And seeing warmth across the entirety of the Western United States is relatively consistent with what we'd expect to see with El Nino conditions. And now just a little bit more about El Nino. El Nino conditions first developed during summer of 2023. So at the end of the 2023 water year, we started switching from La Nina conditions over to El Nino conditions. And by fall, the El Nino had developed into a strong El Nino. So this just means that temperatures are even more above average in the Pacific Ocean. The ocean temperatures are more above average than is typical. This graphic here shows the evolution of those warm waters in the Pacific Ocean throughout this past winter. And then this graph here shows strong El Ninos that have occurred over the past 50 years or so. The 2023 water year, 2024 water year is the purple line, and the gray lines are all of the other strong El Ninos that we've seen in the last 50 years. And you can see that in terms of absolute temperature differences, which is how El Ninos are classified, the 2024 water year kind of ranks in the middle of all of these strong El Nino events. Now, since last year, we saw a La Nina in which the precipitation patterns that were observed completely didn't match what we'd expect. How did the precipitation patterns we saw across the Western US match up to what we'd expect to see with El Nino conditions? And it turns out the answer is, well, they matched up pretty well. The map on the left here is showing relative precipitation conditions in the 2024 water year. And the map on the right is showing the pattern that one would expect in an average El Nino. And in general, the patterns are pretty similar to what we'd expect. It matches the precipitation during 2024 matched the expected El Nino pattern pretty closely, with the primary differences being much wetter conditions in the Pacific Northwest, the Great Plains, and the Northeast compared to what we'd expect from an average El Nino. So the next component of the water year I'd like to go through is the snowpack, but not just how we ended up with peak snowpack, but how that snowpack evolved throughout the course of the year. Because I think there is a little more interest. I think it's a little more interesting looking at how this snowpack evolved. For much of the early part of the 2024 water year, snowpack conditions were not very good. We had a few good storms in October, and then November was quite dry. This map here is showing the SWE conditions as a percent of normal in river basins across Colorado, Utah, and Wyoming. And you can see that all river basins on December 1st were showing below average SWE conditions, and in many cases, much below average SWE conditions. In general, temperatures were slightly warmer than average. Precipitation conditions were very dry, and the warmest temperatures occurred east of the Continental Divide. By the time we get to January 1st, things are not looking much better in terms of snowpack as a percent of normal. December was also very dry. Snowpack conditions improved slightly in northern Utah. We do see near average conditions in the lower Bear River Basin, but we saw record dry conditions in central Wyoming and the Bighorn Mountains. Temperatures were generally 3 to 9 degrees above average during December, and record warm conditions were observed in northeastern Wyoming during December. During January, precipitation was getting a little more close to normal across our region, and this resulted in snowpack as a percent of normal improving somewhat, so that along the Wasatch Front in northern Utah and in the Colorado headwaters and the Yampa River Basin, snowpack conditions were starting to approach normal. We saw above average precipitation and above average temperatures west of the Continental Divide in the region. Now, by the time we moved to March, February was a very, very wet month throughout the entire region, and especially in Utah. In Utah, statewide precipitation was 180% of normal during February. During that month, we also did see above average temperatures across the entire region. So snow levels in many parts of our region were a little bit higher than normal, but the end result was snowpack conditions as a percent of normal improved significantly throughout February, with almost all river basins, with the exception of northern Wyoming, we're seeing near normal to actually above average conditions in much of Utah. Now, by the time we get to peak snowpack on April 1st, conditions continue to be very wet during March, with the exception of northeastern Wyoming, where conditions were very dry. There were actually record wet conditions along the southern Front Range in Colorado. This is largely due to a very large upslope storm that occurred during mid-March that dumped up to 5 feet of snow in the foothills east of the divide. Temperatures in March were near to slightly below normal. And throughout the region, snowpack conditions were really looking pretty good as of peak snowpack. Above average in all of Utah, near average to above average in Colorado, and with Wyoming seeing a mix of near average snowpack conditions to much below average snowpack conditions in the Bighorn Basin and northeastern Wyoming. As we've just crossed over into May, I just wanted to give a quick look at May snowpack conditions. Things look pretty similar compared to April, although we're seeing much less above average snowpack. Much of Utah is near average, with only a few basins still remaining that have above average snow conditions. So the melt really has progressed here in April. And then in some other basins in southern Colorado, the Upper Green, and northern Wyoming, snowpack is below average to much below average. So we have seen more melt in these river basins. And this has largely been driven by much below average precipitation during April and slightly warmer than average temperatures during April. So what does the snowpack mean for what we'll see in terms of seasonal stream flow forecasts? Well, this map here shows seasonal stream flow forecasts averaged by basin across our region. And throughout most of the region, we are seeing the majority of river basins with near average to even above average stream flow, seasonal stream flow forecasts as of April 1st. Above average seasonal stream flow forecasts are forecasted for the Bear, Dirty Devil, Escalante, Lower Green, Jordan River, Six Creeks, and Weber River in Utah, the Bighorn and North Platte River basins in Wyoming, and the Yampa White River basins in Colorado. Near average seasonal stream flow volume forecasts are expected for the Arkansas, Colorado headwaters, Dolores, Gunnison, Rio Grande, South Platte River basins in Colorado, and the Upper Green and Snake River basins in Wyoming. And much of the below average seasonal stream flow forecast conditions are expected to occur in Wyoming, in the Cheyenne, Powder, Tongue, and Yellowstone River basins, also in the San Juan, Sevier, and Virgin River basins in Utah. So we're right at the point, being May 6th, that seasonal stream flow forecasts for May 1st are just being published right now, but not all of these are published quite yet. So I wanted to give you as much information about where we stand a month later looking at seasonal stream flow forecasts. So this map here shows the forecasts that are available through the NRCS as of this morning. And stream flow conditions have, the forecasts have been reduced a little bit, especially for locations in southern Colorado and southern Utah. We're still expecting above average seasonal stream flow in the Lower Bear, Provo River, Six Creeks basins, and the Weber River Basin. Near average conditions are expected for the Upper Bear, Lower Green, Colorado headwaters, Gunnison, and Yampa White River basins. But below average conditions are expected for seasonal stream flow in the Dirty Devil River Basin in Utah, the Upper Green in Wyoming, and the Dolores, Upper Rio Grande, and San Juan River basins in Colorado. So we have seen a decrease in the seasonal stream flow forecasts, particularly in the Upper Green Basin and the Dolores and the Rio Grande River basins over the past month. And that's largely driven by the very relatively low precipitation that we saw over the course of April. So I wanted to real quick, thinking about this comparison between the 2023 water year and the 2024 water year, I wanted to take a quick look at this question about how efficient are we expecting this year's runoff to be, and especially thinking about such a big water year that we had in 2023, that going into the 2024 water year, in many sites throughout our region, soil moisture was at significantly higher levels than it was going into the 2023 water year. So I wanted to take a look at asking the question, well, how efficient is this runoff going to be? So just to remind everyone what I mean by runoff efficiency, an efficient runoff is one where we have 100% average SWE would yield greater than 100% or average runoff. So this would be a scenario where the soils are already relatively wet, so the melting snow doesn't need to go first into really recharging that near surface groundwater. Much of that melting snow can go directly into streams and runoff. This map here is showing sites around the region that have efficient, inefficient, or indeterminate, or I can't determine the type of runoff that we're seeing. So these green circles, efficient stream flow is forecasted. Red circles, inefficient stream flow runoff is forecasted. And these white circles were just within 10% of being efficient or inefficient, and these couldn't be calculated. So efficient stream flow runoff is expected for the Bear, the Duchesne, Escalante, Jordan, Price, Provo, Upper Weber basins in Utah. So much of Utah, we're expecting to have an efficient runoff season. And this really is due to the fact that 2023 was a record snowfall year, and those soil moistures in fall of 2023 were relatively high going into winter. In Colorado, efficient stream runoffs are expected in the Colorado River headwaters, the Yampa, White, and Gunnison River basins. And in Wyoming, the Bighorn, Poposha, Powder, Sweetwater, Wind, and Yellowstone River basins should have a efficient stream flow this runoff season this year. So just a quick look at sites where an inefficient runoff is forecasted, and to remind you of what I mean by inefficient runoff. So this would be a scenario where 100% or average SWE yields less than average runoff, less than 100% of runoff. And inefficient runoff is forecasted for the Arkansas, Dolores, North Platte, San Juan, and South Platte River basins in Colorado, the Fremont, Muddy, Sevier, and Virgin River basins in Utah, and just a couple in Wyoming, the Blacks Fork, Shoshone, and Tongue River basins. I want to briefly touch on reservoir storage in our region. Again, because of the really big water year in 2023, reservoir storage is in a much better place on April 1st of this year than it was on April 1st of 2023. There's near normal reservoir storage conditions in Colorado and Wyoming, and above normal storage conditions in Utah. Utah reservoir storage is running about 113% of median as of April 1st. Statewide reservoir storage is 12 to 25% greater in Utah in 2024 compared to 2023. Many regional reservoirs are expected to fill this year, both because it's an average runoff year, and also because those reservoirs were starting at relatively high levels in 2024. There are some of the large reservoirs that are almost certainly not going to fill. These include Flaming Gorge, Fontanelle Reservoir, Lake Powell, and Navajo Reservoir. And just before I move on from reservoirs, I wanted to briefly talk about Lake Powell. when we're talking about regional reservoirs, a lot of these have filled, but a few of the really large reservoirs in the Colorado River Basin system have not filled and are not going to fill this year. And it would take many years to fill those reservoirs. Lake Powell currently is sitting at 34% of its capacity, full capacity, and 60% of its median capacity. The inflow forecast for Lake Powell this year is 80% of average, with 5.1 million acre feet expected to flow into Lake Powell this year. And this graph here is showing the April 2024 24-month study from the U.S. Bureau of Reclamation. So this is a forecast of how much water is going to come into Lake Powell throughout this throughout this runoff season and the 2025 water year. And just looking at what's forecasted to happen this year, these three dashed lines, the red line represents the lowest possible forecast, the green line represents the most likely forecast, and the blue dashed line represents the highest possible forecast. And this leads to a range of Lake Powell filling to 38 to 49% by the end of July this year, with 41% full and an elevation of 3,585 feet being the most likely forecast for Lake Powell to reach sometime in July of 2024. And finally, I just wanted to talk about what to expect with runoff timing this year. So many of us know about the impact of dust on snowpack. While this hasn't been a tremendously dusty year with lots of dust storms, there was a major dust event that happened in early March that primarily affected the mountains in Colorado, most significantly affecting the San Juan Mountains and particularly the Roaring Fork Basin in central Colorado. This dust event was visible in many locations throughout Colorado. And as snowmelt gets down to that point where it's melted down to this dust layer that accumulated in early March, we should expect more rapid melt occurring once that dust layer is visible. There's some anecdotal observations of a mid-March dust event in the Wasatch Mountains. I don't know that will be that significant of an impact this year, but I brought that up because there was a recent dust has not been studied as thoroughly in Utah as it has been in Southwest Colorado, and it's not monitored in the same way as it is in parts of Colorado. But a recent study showed that snowmelt in 2022 in the Great Salt Lake Basin was happened 17 days earlier due to the deposition of dust on snow. So thinking about these dust events, that's likely going to push the timing of peak snowmelt and peak runoff and those peak flows in rivers to a slightly earlier date this year and shorten the overall runoff season. So far in the melt season, temperatures have been slightly above average in the region during April, but precipitation was much below average. So the combination of dust and so far a relatively dry spring, this is likely going to lead to runoff that occurs a little bit sooner, with the runoff season being a little bit shorter this year. However, as always, weather conditions are going to dictate what happens for the rest of the season. This is a picture from my neighborhood this morning in Salt Lake City. While it's not completely out of the realm of possibility to see measurable snow in Salt Lake City in May, it is pretty uncommon, and we've seen that today. So ultimately, the weather throughout the rest of this runoff season is going to kind of dictate what we see and how quickly the runoff progresses. And with that, I'd be happy to answer any questions.
Awesome. Thanks for the presentation, Seth. That was great. I'm going to check the Q&A now. So it looks like our first question is efficiency defined on soil moisture only or using runoff models? If models are used, which ones?
Yeah, so I took a really simple definition. I think there are varying ways of technical complexity to define runoff efficiency. I was simply in that simplistic analysis was defining runoff efficiency as seeing a higher percent normal of runoff compared to the percent normal of SWE that we're seeing on April 1st. So this would be a forecasted runoff efficiency, not the observed runoff efficiency, since I'm using actual April 1st SWE data as a percent of normal compared to forecasts of seasonal stream flow. And I was using 10% as my margin of error. So I would only call a stream flow forecast efficient if I'm seeing, say, 110% seasonal stream flow forecast compared to 100% or average SWE forecast. So this was a very kind of just relative analysis in this case.
Great. So the next one is how many wet years do we need to refill Lake Powell?
That's a good question. So I've looked at this pretty closely, related to some ecological research that I'm doing in the Lake Powell region. And let me see if I get this number right. So I looked at how many 1983s would it take to refill Lake Powell and Lake Mead. So it's kind of hard to say how many it would take to just refill Lake Powell, because ultimately Lake Powell and Lake Mead are kind of managed together, and the amount in Lake Powell is going to vary. So I believe the analysis I did showed that it would take either 6 or 7 1983 like water years. So the highest water year that we've seen in a row to fill Lake Powell and Lake Mead.
Oh, okay.
And I see a note from DK, Blue Mesa is not expected to fill either. Yeah, that's right. I missed that in saying that. Thank you for adding that, DK.
Awesome. All right, next one. Do the runoff efficiencies account for impacts from wind?
So no, in this case, they would not, because I'm just using the forecast for seasonal stream flow. Ultimately, if you were to look at, ask the question, well, how efficient were runoffs in 2024 using the observed data? Once we have that come in late in the summer, then we could ask questions about if we saw an inefficient runoff. Then we could start to ask questions about climate. Well, why did we see that inefficient runoff? And certainly wind could have an impact on that, sublimating snow at higher rates that wouldn't actually get into the runoff. So the analysis that I did definitely does not consider winds in that. It's a very simplistic analysis, and it's using observed SWE data compared to forecasted seasonal stream flow forecasts. So it's really just a way to think ahead on what we may see in the basin this year.
Great. Could you share more about the dust on snow event that occurred?
Yes. So I know this primarily looking at some of the work that the Colorado Dust on Snow Survey provided. CODOS, I think, is the acronym that group uses. And they, I believe, surveyed snowpack in mid-March and captured that dust layer. I'm not going to get this exactly right, but I think they have 8 or 10 sites around Colorado specifically that they're monitoring dust, that they're going out once a month throughout the snowpack season to record any dust layers that might be there and provide that information that can be useful in a qualitative sense with thinking about stream flow forecasts. And I see that somebody put in the chat the link to the CODOS website. And what I had to say about the Wasatch is really just based on my own observations and observations of people I know who've just been out in the mountains this year. Very qualitative, anecdotal.
Great. All right. As of right now, I don't see any other questions, so maybe we can wait another minute and see if any more come in. Oh, here's another one. So was the La Nina this year considered normal? Is it at all related to the drought in Central America?
So just to clarify, I think the attendee meant was the El Nino this year considered normal? So I guess I can answer that a couple ways. I guess it was not normal in the sense that it was a strong El Nino. So we were seeing a larger temperature differential, more like the above average temperatures in the Pacific were even higher than kind of a moderate El Nino. How that played out in weather throughout this past winter. Here in the Western United States, I would say that this was a pretty typical El Nino year in terms of temperature, precipitation, and those patterns of where we saw above and below normal precipitation. I'd say was pretty much what we'd expect. The drought in Central America, I'm not extremely familiar with that event. I haven't looked at it really closely. I do know that it's been a very, very dry season in Central America. My hunch is that is very much related to the fact that there was a strong El Nino event this year. I can't say for certain, but without more critically looking at the conditions down there, I would say it's likely related to the fact that we had a strong El Nino this year. And that seemed like it was an abnormal event down there, that it was, from what I know about, that it was a very, very dry season. And that might be just related to the fact that it was a strong El Nino event. And these strong El Nino events how they play out in weather is really variable. We had one of the strongest El Nino events in 2015, I believe, that's been recorded. And that winter didn't really, at least in the Western US, it didn't really do what we'd expect an El Nino to do. It was dry. It was a very dry winter and it was dry everywhere, but the precipitation patterns didn't really fit what we'd expect with a very strong El Nino. For example, I think it was kind of projected for that year that maybe the Sierras in the Southwest would see a really big snow year, and it was really dry that year. So it's a little bit of I think there's a little bit of an element of a coin toss on the impact of these strong El Nino or strong La Nina events, like whether that's actually going to lead to kind of an enhanced version of what we'd expect to see.
Awesome. And I'm just curious, Seth, do you know, is there a reason why there's less dust monitoring in Utah versus like southwestern Colorado?
There is some that's been starting up. I think it really just has to do with Southwest Colorado is a hot spot of dust deposition in the Western United States. It's because it's directly downwind of the Colorado Plateau. So all of the desert terrain in Utah, and a lot of that desert terrain has been degraded through grazing, through just the mechanical impact of animals walking across cryptobiotic crusts, has mobilized more soil. So there's this potential dust source that sits directly upstream of the San Juan Mountains in Western Colorado. So it has the biggest source. So therefore, when scientists first started researching this dust on snow issue, that was the spot where it was most obvious that, there's this really significant dust deposition issue. So I think more than anything, that's a hot spot of dust deposition in the West, and it's because where research has been focused.
Okay, thank you. That's interesting. Well, looks like we have a couple more questions. Do you see patterns in the runoff efficiency forecasts that are ongoing? Anything in particular to talk about with the sites where neither was on the map?
I'm going to scroll back to that for a second to see if I can answer that better.
Okay.
So certainly one pattern that I see is the area where there's the most where I'm seeing the greatest areas of efficient runoffs occurring are in Utah, and Utah had the highest, overall soil moisture going into the 2024 water year. And then we're also seeing, say, in southwestern Colorado, most of those sites are showing inefficient forecasts. And although it was a really big water year last year in 2023 in that part of Colorado, soil moistures, like it stayed dry throughout the summer. So soil moistures going into the 2024 water year were relatively lower in southwest Colorado compared to Utah. And then as you go up into Wyoming, I'd say there's not as much of a pattern that I'm seeing, aside from the fact that northern and northeastern Wyoming was there were really dry conditions this year. So I would expect to see inefficient runoffs. And I don't know if I can say anything about neither. That was just a case where I didn't want to say anything that was within 10% of that definition I was using for efficient and inefficient.
Great, thanks. And then also, were the weather patterns for 2023 typical for a La Nina year?
No, absolutely not. They didn't make any sense at all compared to La Nina. Like, yeah, if I had a map showing the precipitation that happened in 2023, kind of as a, relative to normal compared to what we'd expect to see from the average La Nina weather pattern, would look totally different. I think to some degree that had a lot to do with the fact that there were a lot of atmospheric river events during the 2023 water year, and La Nina, the ENSO cycle, and how that impacts atmospheric river type storms. That's not really what that connection is not well understood yet. There's something else different going on there. So yeah, the 2023 water year was not typical of what we'd see for La Nina. It completely didn't make any sense. In general, La Nina should have relatively wet conditions in the Northwest and dry conditions in the Southwest. And we saw just wet to record wet conditions everywhere, especially in the Sierras, which that's really typically associated with El Nino events, seeing above average snowpack conditions in the Sierra Mountains.
Right, great. Well, I think we're all out of questions. It's almost 11:45 Mountain Time here, so I think we'll wrap it up now. And thanks so much, everybody, for joining today's webinar. And thank you, Seth, for the awesome presentation and answering our questions.
Yep, my pleasure.
Yeah, if we did not get to your questions today, or if you have any additional ones after the webinar, just feel free to email us at wwa@colorado.edu, and we'll make sure to get back to you. And we'll be posting the recording as well of this webinar on our website, hopefully today. And yeah, in the meantime, just feel free to reach out to us if you want to keep the conversation going. And lastly, Benet, looks like she put the survey link in the chat. So if you can please take that for us, it'd be very much appreciated. So yeah, thank you. And I hope everyone has a good day.
Thanks for coming, everyone. Have a great day.